Hi guys, and welcome back for another video in our circle topic. Today we are going to be looking at the relationship between the centre, chord and perpendicular bisector. So today we're going to need to be able to use our knowledge of angles and circles in order to solve some problems. First off, a couple of definitions. A chord is a straight line that cuts through a circle in two places. So if we take a circle and then we draw a straight line through it, we can see two places that the line cuts the circle, so that is a chord. A perpendicular bisector is a straight line that cuts a different line in half at right angles. So if we've got one line here, our perpendicular bisector is this one here, splitting at right angles, and we have split this line in half. So our line AB has been split in half by our perpendicular bisector. For a triangle in a semicircle, where one side is the diameter, so in our case A to C is our diameter, the third angle needs to be touching the circumference, so that's this angle up here. Then the angle across from our diameter is always a right angle. So angle ABC is a right angle. This is a really important rule that you need to know for your problem solving, and we're going to be using this a lot today and I think into our next lesson as well. Example number 1 then, we are going to find the two missing angles. So we've been given angle BAC as 48 degrees. We need to find or fill in the other two. So first things first is that A to C is our diameter. B is on the circumference, it's touching the edge of our circle. So we know then that B is our right angle in here, or you could write 90 degrees, up to you, either your square or 90 degrees. We should know that there are 180 degrees in a triangle. So if we add up the three corners, we should get 180 degrees. So what we need to do is add up what we do know, so our 90 and our 48, and that is going to give us 138. And then we need to take that away from 180, which is going to leave us with 42 degrees. So our other angle is going to be 42. Example 2 then, well, we should know that our right angle is going to be this one here at E, because DC is clearly our diameter going from one edge through the centre out to the other side, and E is on our circumference. We're going to do the same thing as before, so 66 plus our 90 is 156, and then 180 take away 156 is going to leave us with 24 degrees. So angle EDC is 24 degrees. Example 3, we need to fill in all of the missing angles. So this time we've actually got two triangles. Now it might look like a rectangle, but E to F is actually much longer than D to C. So it's not a rectangle, we've just got two triangles that we're trying to fill in here. So angle DEF is going to be my right angle here, because DF is my diameter and E is on the circumference. So I can do 90 plus 33 to give me 123, and 180 take away 123 is going to leave me with 57 degrees. My other one then, angle DCF, is going to be my other right angle. So we'll do 90 plus 13 is 103, and then 180 take away 103 is going to leave us with 77 degrees. That's us done section 1, so you can either pause the video here and try question 1. You need to write down or fill in, it's up to you if you want to copy down the diagrams or just write down A equals B equals, up to you. You can do all of the questions from question 1 now, or you can wait until the end and try all the questions on the worksheet. We are also able to use Pythagoras' theorem to find the missing side of a triangle in a circle. So here we've been given RS is 6 centimetres and RT is 8 centimetres. So we're going to find the opposite side here. Hopefully then we remember that our Pythagoras formula is c squared equals a squared plus b squared, where c is our longer side. Now our longer side is always across from our right angle. So using the rule that we've just learned is that angle R here would be our right angle because it's across from the diameter. Our longest side is always across from our right angle in our right angle triangle. So X is our longest side and A and B don't matter as much which way round we put them. So I'm going to be doing X squared then is equal to 6 squared plus 8 squared. X squared then is going to be 36 plus 64. And so X squared is equal to 100. But it wasn't X squared that we wanted, it was just X. So my opposite of squaring something is to square root. And the square root of 100 is 10. My units were centimetres for the other two sides, so my last side must be centimetres as well. And that's you calculated the missing side of that triangle. Example 4 is the exact same idea. So if we have a look then, y to z would be our diameter, x is on the circumference there, so that is our right angle. That means our missing side x is right across from our right angle, so that is side C, and I'm just going to make 7a and 5b. So c squared is equal to a squared plus b squared. So my x value then is going to be 7 squared plus 5 squared. X squared then is equal to 49 plus 25. And so x squared is going to be equal to 74. Now 74 is not a squared number, so we are going to need our calculator this time. And so the square root of 74 is going to give us roughly 8.6 when we round it to one decimal place. That is us worked out our missing side, so we have completed that example. Okay, one more example to go then. So we've got our 20 centimetres and our 16 centimetres. So let's see, y to z would be my diameter. So that means that angle x is our right angle again. But this time that means that 20 is C. So our missing side x then is going to be one of our smaller sides. So I'll just make that A and make 16B. If we are finding a shorter side, we need to rearrange our formula to get a subtract. So our shorter side squared is going to be equal to c squared take away b squared. Now, it always has to be your bigger side take away the other smaller side, so that we are not doing the square root of a negative number. Because it's a takeaway, you always want the biggest side to go first and then take away the smaller side. For this example then, we will have x squared is equal to 20 squared take away 16 squared. So x squared is going to be 400 take away 256. So x squared then is going to be 144. Our square root of 144 then is going to be 12, and it's still centimetres. Now I would like you to try these 5. Again, it's up to you if you want to pause the video and try them now, or if you want to save all of your questions until the end. We've just got one more section to go after these questions here. So this is us talking about our perpendicular bisector. So we can see here that we have got a chord because it is touching at 2 corners, and we are sliding right down here and chopping that chord in half with technically our radius then, because we're going from the centre down here. So because it's a perpendicular bisector, we've got a right angle in that space there. We've also been given the 24 degrees for our right hand corner there. So what I'm going to do is I'm going to work out what angle D is first of all, using just our normal triangle information. So 24 plus the 90 degrees of the right angle. We can then do 180, take away 114, and that is going to leave us with 66 degrees. So angle D then is going to be 66 degrees. What we should spot though is that this line here goes from the centre to the edge of our circle, so it is a radius, and this line here also goes from the centre to the outside of the circle, making it also a radius. That means that this line and this line both have the same size, and if we have got a triangle where two sides are the same, it is called an isosceles triangle. What we should know then is that the two lines that are the same then have two angles at the base of those lines which are also the same size. So that means that angle A is also going to be 24 degrees. They are going to match up nicely. Angle C is also going to be a right angle because we have split 180 degrees in half. So angle C is going to be it's going to be 90 degrees. And if we've got 24 and 90, then we already know that angle B and angle D are going to match as well. So angle B is also going to be 66 degrees. You can see there that I didn't do it in order. I didn't go A, B, C, D. Sometimes it's easier to go in a different order. It's up to you what you find the easiest angle to write down first. So long as you are answering them all, it doesn't matter what order you do them in. Okay, so for example 7 then, it is the same idea. We should notice that we have got a line going from the centre straight down to the edge of our circle, and that is cutting a chord in half at right angles. So we've got a right angle in here, so that's our 90 degrees again in that section there. So maybe you would want to start then, well, if D is on the other side of that right angle, D is 90 degrees. I'm then going to go for B next, I think. So 46 plus my 90 is going to be 136, and 180 take away 136 is going to be 44 degrees. So angle B is 44. We can then write down that A, because this is a radius and this is a radius, A is going to match angle B and be 44 degrees. And then because D is also 90, we know that C is going to match that original 46 degrees. I've filled in all 4 letters, so I know that that is me answered the full question there. The last example then, guys. So we need to fill in all of our missing angles. We've got a lot of information here, so let's just take this piece at a time. I'm going to start with the fact that I've got my centre here. I'm coming straight down, so I know that I've got a right angle here and a right angle here because I'm cutting that chord in half. So I've got 2 right angles there. I know that angle B then, I can do 24 plus the right angle of 90 to give me 114, and 180 degrees in total. Take away 114 is going to be my 66 degrees. So angle B is going to be 66 degrees. That means then that angle A is also 66 degrees, and angle C is also going to be 24. So just to write them down as we go, A is 66, B is also 66, and C is going to match my 24. Now, you're maybe panicking here and thinking, I have no idea how to get E, D or F. But if we covered up the top half of our circle, I'm going to use a different colour this time. We can see that I've got a straight line here going straight through my circle, and we should know that a straight line is 180 degrees. So here, C and E need to make up our 180 degrees of the straight line. So 180, take away the 24 degrees that is angle C, I'm going to be left with 156 degrees for angle E. So angle E is 156 degrees. I've then got the angle E to angle F. That straight line here is a radius, but this line here is also a radius. So I have another isosceles triangle. I know that D and F are the same size, so 180 take away the 156 of angle E is 24. I know that D and F need to be the same size, so if I am splitting something into the same size, I need to divide it by 2. So 24 halved is just going to give me 12. So D is 12 degrees and F is also 12 degrees. That is us filled in all 6 missing angles, plus the 2 right angles really, and that is you answered question 8 there. Well done for sticking with today's lesson, guys. Here is question 3. It is our final question of the day because there is quite a lot of working to get through. Try your best with these questions. Any problems, pop a question in our Teams chat and I will get back to you as quick as I can. Have a great week, guys, and I will see you in the next lesson.